So now let us talk about how vectors can be added. Now let's say if you are given two vectors, let's say a vector, and then from the final point of a vector, there is another vector that starts and it goes up till, let's say, C point. That is our C vector. Then the line joining the initial point of A and the final point of B vector, this becomes our resultant or the sum vector of A vector and B vector. So from here we can say that, let's say this is my C vector, so we can say that C vector is equal to A vector plus B vector. Now this is known as the triangle law of vector addition, or simply if let's say we were given two vectors A vector and B vector and we were given their components a₁, a₂, a₃, b₁, b₂, b₃, and we were to add these two vectors, then we can simply add the components based on the directions. So this was the first most basic form of addition. Now from here what we can see one thing is that we can say that A vector plus B vector minus C vector is equal to 0. If I take this equation here and I take C to the other side, we can say that this equation is equal to 0. And now we all know that if let's say this is my C vector, then the same vector in the opposite direction with the same magnitude, this would become my minus C vector. So now let's say if right now here what we are talking about is we are having a triangle which has one vector in this direction, one vector in this direction, and the another vector in this direction. Now what if I say that this C vector, if I transform this into a minus C vector, so I would have this vector, and then I have this vector. So basically this forms my closed loop. So I can say that this is now my minus C vector. So if I say that C vector is my minus C vector, then from here I can say that A vector, or if I was to represent this by the coordinates, I can say that AB vector plus BC vector minus AC vector is equal to 0. If I were to represent this in the negative way, then this would have become AB vector plus BC vector plus CA vector is equal to 0. So if my vectors are forming a closed loop, then the sum of all the vectors would form 0. So you must remember this thing. Now that loop can either be a triangle, it can be a, let's say, a quadrilateral as well of 4 sides. Let's say if I have 4 vectors in this direction, I have A vector, B vector, C vector and D vector. So the sum of all these 4 vectors would be equal to 0. So you must remember this thing. Now a few properties of laws of addition. If A vector plus B, we have B vector, then that is same as B vector plus A vector. Associative property, A plus B, they are in brackets, so it can be taken out. So grouping basically does not affect the resultant of our vectors. Closure, the sum of two vectors is always a vector. You must remember this. Existence of a vector, if I am adding 0 vector to any vector, it will still remain the same vector because nothing gets changed here. One more property that you must remember is, let's say if I have A vector and I add it with the negative of its vector with the same magnitude, but it is in the opposite direction, so this will give me what? A 0 vector, so, or 0. So you must remember this property as well. Now let's look at another way of addition of vectors. Just now we studied the triangle form. Now we have a parallelogram law of addition. What happens here is, let's say if I have been given A vector and I've been given B vector, and let's say this vector, which is the diagonal here, this is my C vector. So what I'm saying here is that PR vector is my C vector, let's say. So I can say that C vector would be equal to A vector plus B vector. So my resultant can be written in this format. So my resultant can be written in this format. C is equals to A vector plus B vector. Now we must remember that these are, of course, two vectors, and if I shift the vector by, let's say if I keep the magnitude same and I keep the direction same, but I change the initial and final point, it will still remain the same vector. For example, here we had the initial point Q for P for A vector and final point Q for A vector. I've changed it to this part. That means if I shift the vector in the same plane, the value of the vector wouldn't change. So that is how we came to this conclusion that let's say if I assume this is my b vector, this is my a vector. So if I join this line, this would become my resultant of these two vectors. So this is how parallelogram law of addition works. Now let's say if I was to take out the magnitude of this c vector, so it would become a vector plus b vector modulus, and let's say the angle between a and b is theta. So how are we going to find out this value? Let's look at it. So the formula for magnitude of the resultant vector, this is basically our c vector that we are talking about. This would become root under a vector mod square plus b vector mod square plus 2a vector mod plus b vector mod cos theta. This is a formula that you must remember, and theta is our angle between a and b. So this is how resultants a plus b, this can be written as modulus of a vector plus b vector. This is how its modulus is calculated. So you must remember this. Now let's say if a and b are in the same direction, that means theta would be 0 and cos 0 is what? 1. So this would become a vector mod square plus b vector mod square plus 2a vector b vector, and this entire thing can be written as a vector mod plus b vector mod whole square. So simply it can be taken out since it is under the root, so we will get our resultant to be this. And let's say if it is 180, and we know cos 180 is nothing but minus 1, so again it would transform into this value. Now one more thing that you must remember, let's say if my cos theta comes out to be 90, that means my two vectors are at 90 degree to each other. That means my this portion would become 0, so I would be just left with a vector mod square plus b vector mod square. So for now, let's talk about scalar and vector multiplication. Again, a few properties that you must remember. Let's say we multiply a vector with a scalar m, so it would just change its magnitude, the direction would remain the same, unless we have m is negative. If m is negative, then the direction would become opposite to what it was earlier. The resultant of vector m a vector has magnitude mod m into mod a. So basically what we are saying is that if I have m a vectors, this can be taken out as m modulus of a vector. So this is how we can write this. Direction, of course, if m is greater than 0, direction of m is same as a vector, and if m is less than 0, of course it becomes negative. That means my direction of my vector would change. It would become opposite to what it was earlier. This is my distributive property. You must remember this. Again, a few more properties. Let's say if I have m into n and outside I have a vector, so I can simply take out, I can multiply it any way I want with the a vector. Of course it is a scalar quantity. The only thing is that the magnitude is changing, the direction wouldn't change, so it does not matter much here. 0 scalar, if I multiply 0, it becomes 0 vector. Unit magnitude, if m is 1, so the vector remains unchanged. Now let's talk about section and midpoint. Of course we have learnt about this in our straight lines while we were studying it. Let's say if we had 2 points and there was a third point in the middle, but that was dividing the line joining these 2 points in the ratio m is to n, then we used to write down the formula m x2 plus n x1 upon m plus n. That used to be the x or h of the or the point that has been dividing it. So similarly we are using those formulas here. Let's say this is my origin. Here I have my point A, which I represent by a vector. Here I have my point B, which I represent, or the position vector is b vector. There's a line joining here, and there's another third point P here, which I represent as r vector. Now this point P divides this line in the ratio m is to n. So what would be my r vector? R vector can be written in this format. If it divides it internally, it would become plus, and if it divides an external division, then we would have minus in n, and midpoint formula of course remains the same. Again, these are nothing new. These are things that we had studied in straight line. Now instead of coordinates we have vectors here. That is only the major difference. Now let's talk about dot product. This is an important topic for this chapter. Now dot product is basically a scalar product, or basically we are trying to just multiply our direction axis so that we can get a magnitude or a scalar value. So you must remember this formula. if we have a vector dot b vector, then its formula would be a vector mod plus b vector into b vector mod into cos theta, and theta is our angle between these two vectors. Now you can see that this value here, this is a scalar value, because this mod is a scalar, this mod is a scalar, and cos theta is of course going to come out to be scalar. So you must understand that the dot product of two vectors comes out to be scalar. However, when we are going to study cross product, this thing does not happen. We will study that cross products of two vectors gives us a vector only. However, here dot product means it is a scalar product. That is why we also call the dot product as the scalar product. So you must remember this formula. Now one thing that you must remember here is that theta, this theta, we can say that this theta belongs from 0 to pi. Now let's say if my theta is acute, that means my theta lies in the first quadrant. That means we can say that a vector dot b vector, my dot product would be greater than 0. Because if theta is positive, both these magnitudes are of course going to be positive. My cos theta is also positive, so a vector dot b vector would also be positive. However, if my theta is obtuse, that means it lies in the second quadrant, and in the second quadrant we know cos theta is always negative. That means my a vector dot b vector would come out to be less than 0. So this is one more thing that you must remember. Now a few common properties of dot products. If a vector dot b vector, we are doing the dot product, since it is going to come out to be a scalar quantity. If we do the reverse or the commutative of a and b, it is going to come out to be same, which is going to be a vector b vector cos theta. Distributive property, we can simply open the bracket and multiply it as we do for normal any scalar points. Orthogonal vectors, if a vector dot b vector is 0, that means the vectors are perpendicular. So this is an important property that you must remember. Orthogonal vectors, if a vector dot b vector is 0, the vectors are perpendicular. And self product gives us the magnitude of the vector that we are talking about. Now based on this, what one more thing that we can say is that I cap dot I cap, this is the dot product of self vector. So this would be equal to, of course, the magnitude of I cap, and we know what is the magnitude of I cap. It is nothing but 1. So it is going to be equal to 1. Similarly, for j cap dot j cap, this would also be same. And for k cap dot k cap would also be same. So you must remember this formula. And now since they are saying that if two vectors are perpendicular, then their dot product would be 0. That means if I say that I dot j cap, if I'm doing I cap dot j cap, these two are of course perpendicular to each other, so this would become 0. Similarly, if I do j cap dot k cap, these two are also perpendicular, so it would become 0. Similarly, if I do I cap dot k cap, or if I reverse it as well, k cap dot I cap, again this would be 0. So you must remember this formula as well. These two are very much important. Now dot product in component form, if let's say I have a vector as a1, a2, a3, b1, b vector as b1, b2, b3, and if I find out the dot product between them, it would come out to be a1, b1 plus a2, b2 plus a3, b3 simply. Now let's say if I have a vector a vector and I have another vector which is my b vector. Now I'm not defining what are their points. Let's say if I have a question which says, let's say 2 a vector plus b vector dot product this with 2a vector minus b vector. So what is my answer going to be here? First, what would I do is, again, I would do this simply as I do multiplication of two different terms. So first, what would I do is 2a vector into dot product of 2a vector plus b vector dot product with 2a vector plus 2a vector dot product with b vector, sorry, this would become minus because we have minus b here, and minus b vector dot product with b vector. So what would this turn out to be? This would become 4a vector modulus, because we just now studied that if self dot product is taken, then its magnitude square becomes our answer. So that is exactly what we have done here. Plus let us write this one here, minus this would become b vector modulus square, and from here of course we can write b vector dot 2a vector in terms of other ways as well. 2a vector dot b vector, so these two become same, so these two gets cancelled, so it becomes 0. So this is another way how we can calculate the dot product as well. Now this is a formula that you must remember. Sometimes there might be questions that can be asked based on this formula. If let's say you have to find out the magnitude of the sum of 3 vectors and their square, so it is going to be the magnitude of first vector square, the magnitude of second vector square, third vector square, plus 2 times of a vector dot b vector plus b vector dot c vector plus c vector dot a vector. This is an important formula you must remember. Let's look at this question to clear our concepts more about dot product. Let's say we have been given if a vector plus 3b vector is perpendicular to this vector, that means these two are perpendicular to each other, and this are also perpendicular, that means this that means these two vectors are also perpendicular. Then the angle between a and b in degrees is to be determined, so we have to find out the angle between a and b. So as we studied, if there are any two vectors which are perpendicular to each other, that means that dot product would be 0. So from here what we can say is a vector plus 3b vector, this is one vector because of course the sum of any two vectors is a vector. This vector dot 7a vector minus 5b vector, this is equal to 0. So let us do the dot product. What are we going to get? This would become 7 a vector modulus square minus 15 b vector modulus square plus this would become 7 3s are 21 a vector dot b vector. Of course it is going to be b vector dot a vector, but as we know that b vector dot a vector is equal to a vector dot b vector, so it doesn't make much difference. I am writing it as in this format, and this would become minus 5 a vector dot b vector, this is equal to 0. So upon simplifying this we get 7 a vector modulus square minus 15 b vector modulus square plus 16 a vector dot b vector is equals to 0. So this is our first equation. Now let us find out the other equation based on the other value that they have given us. It is a vector minus 4b vector dot product with 7a vector minus 2b vector. This would also become 0. So let us write this down directly. We would have 7 a vector modulus minus or plus 8b vector modulus, and here we would have minus 7 4s are 28, and here we would have minus, so this would become minus 30 a vector dot b vector is equals to 0. So this is our second equation. Now based on these two equations we have to find out the angle between a vector and b vector. So firstly what we can say is that in both these equations we can see that 7a vector, sorry this is squared here, 7a vector mod square and 7a vector mod square is common. So let us subtract these two equations, 1 minus 2. What are we going to get? 7a square, 7a vector square would be cancelled out, so we would be left with minus 15 b vector mod square plus 16 times of a vector dot b vector minus 8 b vector modulus square plus 30 times of a vector dot b vector. This would be equal to 0, and upon solving this further what are we going to get? This would become 46 a vector, sorry this would become 46 a vector dot b vector equal to this would become 23 b vector modulus square. So from here we can see that 23 cancels out 46 with 2, so here we get b vector modulus whole square is equals to twice of a vector dot b vector. So this is our third equation that we are getting. Now from here what we can do is, since we've gotten the value of b vector, let us substitute the value of b vector square in any one of these equations, so that what we can do is we can find out the value of a vector modulus as well in terms of a vector dot b vector. If we find that out, that means we can find out the relation between modulus a and modulus b, and once we find that out, it would become very easy for us to find out the angle between them. So let us put the value of b vector modulus square in let's say 2 equation. So 3 used in 2. Second equation, what do we get? 7 a vector modulus square plus 8 times of, we have b modulus square, so this becomes twice of a dot b, so we can write this as 16 a vector dot b vector minus 30 times of a vector dot b vector, and this is equal to 0. So from here, a vector modulus, what would that come out to be? This would become 14 times of a vector dot b vector, so again this would become 2 times of a vector dot b vector. So this is our fourth equation, and we know that 2 times of a vector dot b vector is what? B vector modulus, so this can be written as b vector modulus whole square. That means one equation that we've gotten is this square is equal to b vector whole square. This is our major equation that we've just found out. Now I hope you all know how do we represent a vector dot b vector. This is going to be a vector modulus plus b vector modulus cos theta. From here, a vector dot b vector, what do we know about a vector dot b vector? It is nothing but a vector modulus square by 2, so we can write this down as a vector modulus square by 2, or you can write this down as b as well. Here what we are doing is, now we can convert b into a as well, so this can be written as this value only, cos theta. From here, this and this gets cancelled, so we have cos theta is equals to half, and cos theta, when is it half? When theta is equals to 60 degree, or pi by 3. So this is our answer. This becomes our answer. So that is how these type of questions of dot product are calculated. Again, you have to keep a lot of patience and keep full attention while solving these questions. Otherwise, there can be a lot of confusions created while solving such questions. Now we will look into the cross products.